Today we will continue with exercise 1.3. Determine whether the given ordered pair satisfies the equations. An ordered pair has always its first coordinate corresponding to x coordinate and the second coordinate corresponding to y coordinate. So if we just substitute instead of x 2 and instead of y 3, so substitute x by 2 and y by 2, 2 over 3 actually, we will get under A 2x plus 3y is equal to 6. Now we have 2 times 2 plus 3 times 2 over 3. This should be 6. Now 2 times 2 it's 4, plus we can cancel out 3 and 3 here. So what do we get? That's just 4 plus 2, which is 6, and actually 6 is equal to 6. So the first pair, ordered pair, satisfies the equation. This one satisfies the equation. Under B, we have x minus 2y is equal to 5. So now we have to substitute x by 2 and y by negative 3. So 2 minus 2 times negative 3 should be 5. 2 plus 6 should be 5. That means 8 it's 5. Well, this is not quite true. So this is not equal. That means this pair does not satisfy the equation x minus 2y is 5. We have another pair here under C, which is exactly for the same equation. X minus 2y, it's 5. We substitute x by negative 1 and b by 9, so we got negative 1 minus 2 times 9. That should be 5. So negative 1 minus 18 is 5. Negative 19 is 5. This is not true, so the third point doesn't satisfy the equation as well. Let's continue with the second exercise. Draw the graph of each of these equations. Under A, we have x plus y, it's 5. So if we take a table with some points for x and some points for y, obviously we just need to take at least 2 points. It would have been easier if you pick once x 0, once y 0. If x is 0, that means y is 5. If y is 0, x is 5. Maybe just for precision we can take one more point. It's not necessary, but let's take for x2, y is 3. Alright, now we just need to find where do these points lie on the number line. It will be free-handed drawn like this, but it will be quite enough. So now if x is 1 here, 2 here, 3 here, 4 here, 5 here, 1, 2, 3, 4, and 5. Now the first point here is the point with coordinates 0, 5, which corresponds to x0, y5. It's this point. Then 5, 0, which corresponds to this point, and 2, 3, which corresponds to this point here. So now we can clearly see there is this line passing here. So we can show that line passing like this. So this is the line under A. Let's see under B. We have x minus y, it's 4. Again, we can take some points here, point x and y. Let's say now we will take only 2 points. If x is 0, y would be negative 4. If y would be 0, x would be 4. So now we don't have to show all these points on x-axis and y-axis. It's enough on x-axis to have this range from 0 to 4 and on y-axis to have this range from -4 to 0. So that would correspond to maybe this graph looking something like this. So only the positive side of x-axis and only negative side of y-axis. So now we have if x is 0, y it's 4. Actually, if x is 0, y it's -4, so it should be here. And if x is 4, y it's 0, this should be that point. So let's point this point and this point here. Of course, there is only one line passing through these points. If just in case you wanted to take any more points, you can feel free about that. Let's solve the last two cases using the xy intercept method. Under C, we have 3x plus 6y is equal to 12. If you remember during the lessons, we were dividing both sides by 12. So we got 3x over 12 plus 6y over 12 is equal to 1. We can simplify both these numbers, so we get x over 4 plus y over 2 is 1. Well, the same way as previously, this number here corresponds to x-intercept, and this number here corresponds to y-intercept. So let's graph this one. X-intercept is 4, y-intercept is 2. That means the line is passing through these 2 points. And the last one under D, it's 2x minus 5y, it's 10. We can divide both sides by 10, and what do we get? We get x over 5 after simplifying, minus y over 2, it's 1. Well, the xy-intercept formula had a plus here, so in order to get a plus there, we need to pass that negative sign to the denominator here. So again, x-intercept is 5, x-intercept is 5, and y-intercept is -2. So let's see, if x is 5 and y is -2, it should look something like this. So x5, y -2, and the line will lie somewhere here. All right, let's continue with the third exercise. Solve each system of equations using the graphing method. Now, we can start graphing these equations. Under A, we have two equations. The equation x minus y is equal to 4 and x plus y equals to 2. You can clearly see that using the elimination method it's easier, but it's requiring from us to use the graphing method. So let's graph these two lines. Again, I can use xy intercept method. So dividing both sides by 4, I do get x over 4 plus y over -4 equals to 1. And on the second equation, I'm dividing both sides by, here dividing both sides by 4, here dividing both sides by 2. I'm getting x over 2 plus y over 2. That should be 1. All right, so expressing it on the coordinate plane, So 1, 2, 3, 4, 5. 1, 2, 3, 4. Same for negative numbers. So for the first point, let's use an orange color for the first equation here. It's crossing x-axis on x4 and y-axis on y-4. So this should be that line. And the second line is crossing x-axis on 2. Let's use a green color here. And y-axis on 2. So this would be the solution. Now, this being the solution at this point, it looks like it's crossing at the point with coordinates 3, -1. Under B, we have a system of equation x minus 3y is equal to 5 and x plus 2y is equal to 10. We can use exactly the same method again, so xy intercept form. If we divide here by 5 and here by 10, we can clearly see that we will end up using some fractions, but I don't think it will be a problem. We can estimate a bit. So it will be x over 10 plus y over 5. It's 1. The second equation, the equation of the second line here, it doesn't have any fractions here. So, but the first equation do have a fraction. We get x over 5 minus 3y over 5. So just working out a bit these numbers, let's see. We get x over 5 plus, we should have y over something, so that means it will be 5 over 3, negative 5 over 3 actually, equals to 1. Here it should be equals to 1 as well. So finally we have x-intercept and y-intercept for the first line, and also x and y-intercept for the second line. Let's see, now we have so 5 here, 10 here. For y, 5 looks like somewhere here, and 5 over 3, it's 1.6, close to this point here. Right, so the first line is passing through x5 and y negative x5 and y negative 5 over 3. There should be negative sign here. So this is that line. And the second line is passing through x10 and y x10 and y5. We can check if we graph this one properly, we would have seen the actual answer. Here it's not clear enough. I think it should be something like 7 x7 y1. Graph this one properly and you'll get the answer. Let's see under C. So under C, what do we get? This time let's use maybe the table method. We can take 3 points for better precision. Let's take each time like x0, y0. This x0, y0, it's exactly the same method like with the x and y intercept. If we don't want to deal with fractions, we can pick some numbers that will remove those fraction parts. Anyways, we can stick with this. If x is 0, y would be 8 over 3. If y is 0, then x would be 4. We can take also x being 1. So if x is 1, y is 2. Now, this was for the first line here. And for the second line, let's take another color. X, y. We can take again these 2 points, x0, y0. So if x is 0, then y would be 3 over negative 2. If y is 0, then x would be 3. We can take also x1, one extra point here, which gives us that y is negative 1. All right, perfect. Let's show now this on the number line, on the coordinate plane actually. So if x is 0, 8 over 3, 3, 4, 5, 1, 2, 3, 4. Hopefully that's enough. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 8 over 3 corresponds to 2.6. So if x is 0, 2.6 is somewhere here. If x is 4, y is 0, that corresponds to the point here. And if x is 1, y corresponds to 2. You can clearly see the red line is passing here. And let's check for the second point. If x is 0, y is negative 3.2, which is negative 0.5. Here, if x is 3, y is 0 here, and if x is 1, y is negative 1 here. If we are drawing a line here, it looks like it looks like the intersection, which is here, is something like 3.5x, 3.5 for x, and y maybe 0.5. But draw it properly and you'll get a precise answer. And the last system, under D, we have 2 over 3x minus 1 over 2y equals to 5 over 2. 2 over 9x plus 1 over 3y, it's 14 over 9. In order to get rid of these fractions, it will be way easier if we didn't work with these fractions. We can multiply the first equation by 6 and the second equation by 9. So after multiplying by 6, you'll get 2 over 3 times 6, which will be 4x minus 3y equals 15. And the second equation would be 2 over 9 times 9, that's just 2x, plus 1 over 3y times 9, that's 3y, equals to 14. Well, now we just need to take some points here. You can clearly see using elimination method would have been way easier in this case, but we have to use the graphing method again. So we can take some points. We can take some points here. Let's take only 2 points. If x is 0 and if y is 0. If x is 0, y is negative 5. If y is 0 on the first equation, then x is 15 over 4. On the second line, we have something like If x is 0, y it's 14 over 3. If y is 0, x it's 7. So the first point, which is 0, negative 5, we need to show the increments here as well. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4, 5. All right. X 0, y it's negative 5 here. Y 0, x is 15 over 4. It's 3.37, so 3 and 3 quarters, which corresponds to that point. Perfect. And next line, if x is 0, y it's 14 over 3, which is something like 4.66. X 0, 4, 1, 2, 3, 4.66. It's very close here. And for x 7, which is here, y is 0, so it looks really close. Maybe it will be half or 1. The intersection would be somewhere at maybe x 1 over 2 and y negative 4. So something like this, close to this one. Let's continue with another exercise. Solve each system of equations using the elimination method. Actually, the elimination method would be the method that we will mostly use. X plus y equals to 5 and x minus y equals to 3. If we just add these side by side, left-hand side of the first equation added to left-hand side of the second equation equals the right-hand side of the first one plus right-hand side of the second one, we get x plus y plus x minus y. It's 5 plus 3. Cancel, cancel. 2x, it's 8. Divide both sides by 2, we get x is 4. Now that we figured out that x is 4, you can go back and substitute either here or here. Doesn't matter. Let's substitute on the first equation. So 4 plus y is 5. Subtract 4 from both sides. Y it's 1. Let's try to do the same on the second equation under b. So under b we do have 2x minus y, it's 15, and negative x minus y, it's 6. There are two ways to get opposite coefficients, or coefficients with opposite terms here, 2 and negative 2, or maybe 1 and negative 1. We either multiply the second equation by 2 to get opposite terms, like here to get a negative 2, or we multiply here by negative 1 to make this negative y term a positive y term, and now we do have opposite terms, or maybe multiply the first equation by negative 1. I think it would be better if we just multiplied everything by 2. So now we do get 2x minus y, it's 15, negative 2x minus 2y, it's 12. So now adding side by side, if we add side by side, these two terms will cancel. So minus y minus 2y is 15 plus 12. Negative 3y is 27. So that makes y equals 27 over 3, actually negative 3, that's negative 9. Now that we figured that y is negative 9, We can substitute wherever we want, maybe on the first equation. 2x minus negative 9 is 15. 2x plus 9 is 15. 2x is 6. That means x is 3. Let's continue. Solve each system of inequalities using the elimination method, just like previous. Under C, we have 4x plus 3y equals to 12. 2x minus 4y equals to 6. So in order to get opposite terms here, it would be enough to just multiply the second equation, both sides of the second equation, by negative 2. So what do we get? 4x plus 3y is 12. Negative 4x plus 8y is equal to negative 12. Now when added side by side, 4x and negative 4x cancels. Now we have 3y and 8y, that makes 11y. 12 and negative 12, that's 0. So y it's actually 0. If y is 0, you go back and substitute maybe on the first equation here. So we get 4x plus 3 times 0, it's 12. 4x is 12, x is 3. So this is the solution for the system under C. What about under D? We have an equation like this. 3 times 2x minus 1 equals to 5y. 7 times x plus 1 equals to 4 times y plus 4. 4 times y plus 4. The first thing that we should do on this equation here would be to get rid of these brackets to make this equation look a bit more in a more familiar form like here. So we get 6x minus 3 is equal to 5y. On the second equation we get 7x plus 7 equals to 4y plus 16. So we get 6x minus 5y is equal to 3, and 7x minus 4y is equal to 9. In order to get opposite terms on these equations here, we can multiply the first equation maybe by 4 and the second equation by negative 4. Negative 5 actually. Why we are multiplying by these constants? In order to get opposite terms here. So finally we have an equation that looks like this: 24x minus 20y is equal to 12, and negative 5 times 7, that's negative 35x, plus 20y, that's negative 45. All right, added side by side, these two terms will just cancel. So 24x minus 35x is 12 minus 45. That makes 11x is equal to 33. So x is just 3. Now that we figured out that x is 3, we can go back and substitute in either equation, but maybe it would be easier to substitute here. Maybe. Why? The numbers are smaller and we can work out easier there. So 6 times 3 minus 5 times y is equal to 3. 18 minus 5y is equal to 3. Negative 5y is equal to 3 minus 18, that's negative 15, y it's 3. So x3, y3.
We have two more examples left from exercise 4. Let's continue with E. So x over 6 plus y over 6 is equal to 5 over 2. And the second equation, x over 9 minus x over 9 minus y over 9 is 1 over 3. We can multiply both sides of the first equation by 6 to get rid of the denominators, and both sides of the second equation by 9 to do exactly the same with the second equation. So we get x plus y is equal to 6 over 2, that's 3 times 5, it's 15. And x minus y, it's equal to 9 over 3, that's 3. Now if we add these side by side, what do we get? Negative y and y will cancel out after adding side by side. So you get 2x is equal to 15 and 3, that's 18. So x is equal to 9. After you get that x is equal to 9, you go and substitute in either one of these equations. Let's say we substitute here, we get x minus y is x minus 9 actually. X minus 9 is equal to 3, so x is equal to 12. So we got these two solutions. Y, 1 second, I substituted on y. So 9 plus y is equal to 15. Y is equal to 15 minus 9, that makes it 6. So x is 9 and y is 6. What do we have under f? Under f, we have x plus 2y over 3 is equal to 4, and 2x minus y over 2 is equal to 2. We do the same here. We multiply the second equation and the first equation, the first one by 3, the second one by 2 to get rid of the denominators, these two ones. So let's see. We have x plus 2y is equal to 12, and 2x minus y is equal to 4. Now again, we don't have opposite terms, but if you multiply the second equation again by 2, what do we get? We get 4x minus 2y is equal to 8. X plus 2y is equal to 12. If we add these side by side, on the left side we get 5x is equal to 20. Divide both sides by 5, we get x is equal to 4. After finding x, you go and substitute in either one of these equations, doesn't matter. Let's substitute on the first one. So 4 minus 2y is equal to 12. Negative 2y is equal to 8. After dividing by negative 2, y is equal to negative 4. So this is how we solved the last example from exercise 4. Solve each system of equations by using the substitution method. All right, the substitution method had one very important part, which was expressing one of the unknowns on the equation in terms of the other unknown. In this case, let's say under A, we can express x as 13 minus y. And now after we got that x is 13 minus y, we substitute on the second equation, which is here. We substitute wherever we have x, we substitute by 13 minus y. Meanwhile, the first equation will just remain as it is. So we get 13 minus y, it's equal to 5. So we get 13 minus 2y, it's 5. x is 13 minus y. Now we have negative 2y is 5 minus 12, that's negative 8. X is 13 minus y. After dividing by negative 2, we end up that y is 4. And then you go back and substitute on the first equation, 13 minus y, but y is 4, so that makes y 4 and x 9. The second equation under B, the second system actually, is 3x minus y equals to 18, 2y plus x is equal to 6. We can express any of these variables in terms of the other, but it's easier, I think, to express x as 6 minus 2y. And then you go back on the first equation and you substitute 3 times x, which will be 6 minus 2y, minus y, it's 18. Now from here on, the second equation, we will just copy it, 6 minus 2y, get rid of brackets, 8 minus 18 actually, minus 6y minus y is equal to 18. So we get negative 7y is equal to 0. X is equal to 6 minus 2y. So after dividing by negative 7, y is 0. If y is 0, x is 6. Doing the same with the last equation, well, here we can clearly see we have some fractions. In order to get rid of those fractions, we will perform just the same operations like previously. So we will multiply by a number to get rid of all these denominators. If you multiply the first fraction by 6, which is the least common multiple of 2 and 3, and the second fraction you multiply it by 30, you will get rid of all these fractions. So what do we have here? Well, we have 3x plus 2y is equal to 3 times 6 over 2, that's 9. And 30 over 3, 10x minus 5y is equal to 3. Right, we can express here, for example, 2y in terms of x, but we will end up having fractions there. Let's try to do that one. Meanwhile, we can find a way around this fraction by multiplying maybe both equations by some constants, and instead of expressing y in terms of x, we can express 2y or 5y or 10y. In this case, it would be actually 10y. So let's see, y is 9, 2y is 9 minus 3x. Copy the second equation. That means y is 9 minus 3x over 2. When you substitute on the second equation, you get 10x minus 5 times y, but instead of y, we will write 9 minus 3x over 2. That's equal to 3. So because I don't have enough space, I will have to erase some parts here, and we will continue there. Let's continue solving only the second equation. Now 10x minus 5 times 9, it's 45. Minus 5 times 3, that's 15x over 2, it's equal to 3. We can multiply both sides by 2. We get 20x minus 45 minus 15x, this one should be in brackets, is equal to 6. 20x minus 45 plus 15x should be equal to 6. So 20x plus 15x, that's 35x is equal to 51. That makes x equals 51 over 35. Now that we figured out x, we can figure out y by substituting here 9 minus 3x, which will be 3 times 51 over 35 over 2. This is 9 minus 153 over 35, all this over 2. 35 times 9, 350, 350 minus 35, that's 315, and that makes 7 times 2, 70. I'm skipping a step here. 231, 16. So 162 over 70, we can simplify by 2, we get 81 over 35. Let's continue with another exercise, which is exercise 2, exercise 6 actually, on the first example. Instead of, we can pick different ways to solve these kind of equations like this one. We can multiply here by 2, and what do we get? X minus 2y is equal to 2, x plus 2y is equal to 10. Add them side by side. 2x is equal to 12, x is equal to 6. Let's try the same here. We can multiply this one by 2, and you get 2a plus 3b is equal to 8, 2a minus 4b is equal to 8. Now you can clearly see we don't have opposite terms, but instead of adding, we can subtract them side by side. 2a minus 2a is 0, 3b minus negative 4b, that's 7b. 7b is equal to 8 minus 8, 0, which makes b 0. If b is 0, we can substitute wherever, but I think it would be better if you substitute here, and you get a minus 2 times 0, it's 4, which makes a 4. Now on this exercise, because I have x equals to this one and x equals to this one, we can just set up right side 2y plus 5 is equal to 11 minus 4y, just substituting there. Now we can add 4y and we get 6y plus 5 is 11. Subtract 5, we get 6y, it's 6, which makes y 1. After you get that y, it's 1, you can substitute whatever, maybe on the first equation. X is 2 times 1 plus 5. X is 2 plus 5. X is 7. Same goes for the equation here. We can solve it in different ways, maybe substitution or maybe trying to get opposite terms. Let's see, we can multiply here by 4 and here by 4 as well. So multiply by 4. What do we get? We get 3x minus 5 plus 4y is equal to 0. And here 4x minus 5y plus minus 1 is equal to 0. All right, we can express it 3x plus 4y is equal to 5, and 4x minus 5y is equal to negative 1. Next, we do have two equations, so we can multiply both of these equations. For example, this one by 4 and by 3 actually, or let's multiply by 4 for cancelling y, and this one by 5. Now what do we have? We have 15x plus 20y is equal to 25, and 16x minus 20y is equal to negative 4. Add them side by side, we get 31x is equal to 21, which makes x 21 over 31. Go back and substitute x wherever you want here, and you can find y. You can check that one homework. And the last one would be this equation, which I will just give you a hint how to start solving it. So if you multiply the first equation by x and the second equation by y, you will get 2x minus 3y minus 10 is equal to negative 2x, and negative 6x plus 3y plus 6, it's 2y, and we can add 2x to get rid of these 2x on the right side. So 4x minus 3y minus 10 is 0. We can subtract 2y, so negative 6x plus y plus 6 is equal to 0. You can continue this with the same methods that we used previously. Have a nice day. Bye.